Welcome to the RhoMobile Suite Webinar Series. Thanks for joining us today. Today we have a very good topic, and let me just kind of go through some of the items that we're going to talk about today. First of all, I want to welcome back some of those who to this webinar series. We've started this webinar series up again, and I just want to go through a couple things about what we plan on covering and how we're going to do these webinars going forward. So I'll just spend a couple of moments on that really quick, and then we're going to get to the topic of the day. And today's topic has a lot to do around performance, and particularly around HTML5 performance. And we have here today Ben Kennedy, who is one of our lead software engineers from the RhoElements team, here to go over a presentation. And then kind of a new tradition that we started with these new webinars is that with each webinar, at the end of the webinar, we're going to do a very quick kind of resource of the week. So typically this will be something that I found in dealing with customers in real situations and solving a particular problem. And it'll only take a couple of minutes to cover, so I think you'll be interested in staying tuned to the end of this, right? Just a couple of housekeeping notes on the webinars. If you do have a question, please ask the question via the GoToMeeting tool. So this way we can capture the questions, we can hopefully answer the question before we get to the Q&A section at the end, and then also we'll post those questions online with the recording of the session, so this way the content will be searchable. And as I mentioned, the sessions will be recorded and posted on Launchpad. There's a little QR code that you can take a snapshot on where you'll be able to get back to the recording once it's up there, and we should have it up there in the next day or two. And then also, if you can kindly please, when you exit the webinar, if you can please provide some feedback on today's topic, how useful it was, as well as any suggestions for new topics going forward. That would be much appreciated. All right, so we're starting the new webinar series. We're going to shoot to have these every Wednesday at the same time. Okay, they will be recorded, like I said before, and here's the URL to find where we'll be posting all the webinars. We've taken what previously existed from the RhoMobile community as far as previously recorded webinars and videos, and also posted them to this site as well. So this will be the central location for you to find how-to videos, webinars that we record. And typically we're going to focus our webinar series around a couple of different types of topics, whether it's going through actual code and demonstrations, demonstrating certain features, or discussing some best practices like we are today. So again, this is a community kind of driven content, so your feedback will help shape the types of content that we'll be producing for these webinars. Participation is very key, so please, like I said, drive the content, submit the feedback, and also to get notified of the webinars, there's a couple of different things you can do. When you visit that URL on Launchpad, you'll be able to follow the community and actually get notifications for webinars in general, and also when we post the videos, you'll get an email notification. And then you can also just subscribe to just a particular webinar of your choice by registering with the GoToMeeting link. So be sure you check that out. And just a point here, this follow button will not appear if you're not registered on the site. So if you visit the site and you don't log in, you'll still see the videos and content, but you won't be able to subscribe that way. So please do register, and you'll get some notifications. Our next topic next week is going to be presented by Jeff Poremba, who you may know. He'll be discussing some concepts around direct database connections and synchronization with RhoConnect. So be sure to attend that session. Originally we're planning that for today, but what we decided to do was to push that out to the following week because we're going to be doing this performance presentation today. Just so you know, some of the other topics that I've gotten feedback on, and these are the kind of the works in progress. We're looking at demonstrating RhoConnect Push, which is a new feature that has been put out there in the latest release, as well as showing you how to build RhoMobile applications for big windows. So these are some new features that we want to demonstrate, but also we have a big push on performance, and that's why we're doing this presentation today. So you're going to see a lot of webinars and also blog posts around performance items and how you can ensure your applications are performing the best way. So here's some ideas that we had down. If you have other concepts that you want us to cover, like I said, please feel free and let me know. Also, if you would like to be a guest speaker on these webinars, there's definitely opportunity for that. So maybe you develop the latest and greatest, jQuery widget, or you have other things to share with the community. Please reach out to me. Not only you have an opportunity to present on the webinar, but we also have some guest blogging opportunities as well. So there's my email address down there, rob.galvin@motorolaSolutions.com, and looking forward to the community participating in these sessions as well. All right, so today's topic is Ben Kennedy, is presented by Ben Kennedy from the UK RhoElements team, and he's going to cover some concepts around HTML5 performance techniques. Before we get into Ben's presentation, I just wanted to point out, and I don't know if the community has noticed, but lately we've been really kind of driven around this whole performance concept. We actually have a task force that is made up of the engineering teams, as well as our field software specialists, in really trying to make sure that not only we're promoting best practices around performance, that also we're taking some of these real deployment scenarios, experiences into the product and either making enhancements in the product, and also making sure we're staying in tune with any performance related issues. So Darren Campbell had posted 2 blog posts on performance. The latest one is around just configuration settings. So there's some configuration settings that can really, make your application perform quite nicely. So be sure to check those out. Again, go to the developer community on Launchpad and just click on the blog button on the left-hand side, and you'll get to the recent blog, and definitely check those posts out. Okay. All right, so that's enough from me. Let me turn your attention over to Ben. Ben, welcome. While I'm enabling your screen, if you can just introduce yourself.
Hello, everyone. As Rob said, I'm Ben Kennedy. I've been working on the RhoElements project for the last 2 years as part of the RhoMobile Suite. For the last year, I've been concentrating more on HTML5 and the technologies around it. And that's why I've chosen to do this presentation on what I've learned and researched on how to improve performance, speed, size, and tips and tricks on making your web app faster, smaller, and better. This is important because on low-powered devices such as any handheld device, you need to make the most out of your programming because they are low-powered devices. Now, you might think that's a bit weird with the ET1 tablet having a dual-core processor, 1 gigahertz. It seems a rather powerful machine, but compare it to a normal desktop, it pales in significance. So, these are the technologies I'll be focusing on today. Of course, HTML5, and then the 2 which always go with it, CSS3 and JavaScript. I'll also be touching on Motorola RhoElements, as that's what my focus is upon. And we'll be using Google Chrome and the developer tools in it. I'm using Google Chrome because it is a WebKit-based browser, just as RhoElements is. So this is just the legend of how the presentation is set up. The top right here, it will show which technologies that the page is related to, and the bottom section here will show what type of performance increase the page is describing. Right. So this is the contents of what we're going to be looking at. It's split up into 4 sections, as page times are generally split up into 4. The navigation, so going from one page to another, loading of the page, the time taken to load the page and all its resources, using the page, which is more to do with user responsiveness and fluidity, and then leaving the page, getting more data. So to dive straight in, we'll start on the navigation topic. So the first thing to say is the internet is slow, therefore use it as little as possible. This sounds a little bit strange coming from a producer of a web framework, But if you compare the internet and its speeds compared to, well, for example, a hard drive, which is one of the biggest bottlenecks of a modern computer, a hard drive may take 4 milliseconds. Is that correct? 4 milliseconds to start reading a piece of data. Have I got that wrong? Is that microseconds? I can't remember. But anyway, the internet is much, much slower, at an averaging about 100 milliseconds to load a page. So therefore, use it as little as possible. Use it efficiently. So this navigation section split up into 4. Loading local versus loading remote, using redirects, the speed of the server and the location of the server, all related to the speed increases for web apps. So, as I said, use the internet as little as possible. So it would seem like the least used, if you want to use the internet least, then don't use it at all. Local pages, we shall see local pages load a lot faster than remote pages because they don't use the internet. For example, we have a local page here and a remote page. This is loading the same page. If we try them, so that loaded this page, and I'm using a bookmarklet, which is linked to at the end to show the speed of it. This bookmarklet uses the performance JavaScript object, which is a fairly new feature of HTML5. And it gives us values, many different timing values of the page that's just loaded. So if we have a look here, so this page in total took 122 milliseconds to load, but we can see that the network took in between 0 and 1 milliseconds. That's because there was no network, it loaded from the hard drive. While if we compare this to a remote page, and then check the performance on here, so that it took 831 milliseconds that time. So that's about a 7 to 8 fold increase. The network was taking 553 milliseconds of that. So that's why loading from local sources can provide a very big speed increase. But of course, this is not always, well, it's very seldom is going to be useful because you can't get new data, you can't get dynamic data. And that's what most web apps are doing, is getting map data or customer report data or sales data. Also, the markup is stored upon the device, which can make it vulnerable to being copied or stolen. For some customers, this is important because this is their IP. And so having it on a server, having it encrypted, can be more useful. So the second part, redirects. A redirect is an HTTP 300 or one of the 300 response codes. So this is when we send an HTTP message to the server requesting for a resource. The server then responds to that message saying, it's not here, but I know where it is, go to this page. For each redirect, there is 2 HTTP messages. So there's 2 transits of the network to the server. And this is what we're wanting to reduce because this is where the latency is. So therefore, be direct, don't redirect. It takes up a lot of wasted time, which is, is completely wasted. So I've got another one which redirects twice. It's using the bit.ly and goo.gul services as URL shorteners. So I'm going to now use Chrome's developer tools by pressing F12. And among the tabs they have here, the timeline tab is one we'll be using. So this will record what's happening in the network side of things and how the loading is going, and also JavaScript timings. So if I start recording and hit this link, no, I've got the wrong one. Try the network one. That's for later. Okay, so this is our network. this is the different network requests that we've put across the network. This is the first one, which is the bit.ly, and it's taken 324 milliseconds to be able to get that. The second one, the goo.gul, only took 9 milliseconds, but still, that's a long time before we can get the main page from our server. So basically, just don't do it. There's no need for mobile web apps to have redirects, or if there are, they're very, very seldom. So the next one is to do with server location. So you might have no redirects. You might have very, very fast fiber optic cable connection. But still, it's going to take a long time if the server is on the other side of the world. So here's an example. We've got our device here, which is probably in Indonesia or Japan, and our server, which looks like it's in Mexico. To send a request from one to the other, going at the speed of light. So, for example, if we have a perfect fiber optic cable that never degrades, going directly on the Earth's surface, this is going to take 66 milliseconds. And that's the fastest it could take, unless it's going through the center of the Earth. So, and of course, if you've sent one request, you need to have a response. So it's two significant figures. That's 130 milliseconds wasted. So, and of course, this is the best use case. You could have worse cable, and for the internet, it's a web. So the requests will need to be read by servers and routers and switches, and passed along different cables. It's not going to be a direct link. Even going by satellite, geostationary orbit is 36,000 miles out. So it's going to be a lot longer than going along the surface of the Earth. So therefore, if, for example, your mobile web app is being used solely in a store, then have the server in the back end of the store. This will reduce the latency which is involved in the network. So, but of course, this will pale in comparison if you're using a bad server. For example, if you've got the latest Motorola ET1, but are running your server as an old BBC Micro, the speed of processing on the server is going to be very high. So let your server hardware and software be well suited to what your web app needs. Okay, move on to the next set. This is to do with the loading. And this is the time taken from when we've got the first response from the server, and but to the time when the page is usable. So the first improvement is to externalize styles and scripts. So this is a slightly contentious issue because there are advantages and disadvantages of doing this. So to externalize the styles and scripts, this means not having the CSS or the JavaScript within the main HTML page, but to have it as separate files. The advantage is the caching can occur. So while if the HTML file can't be cached, then the CSS and JavaScript can be. And if you're using common CSS and JavaScript files, this means they'll be cached once and used across all pages. It'll also make the HTML files smaller, which means that the page will load faster because there's less data to transmit and read. But, of course, as we just said, HTTP requests are expensive, and external files will require an extra HTTP request and therefore response as well, which can increase the time. This is a bit of a common sense one. Remove the JavaScript and CSS that you're not using. If you've written a wonderful jQuery-like language but don't use it in a page, you could be wasting hundreds of kilobytes of network download and also having to be parsed by the browser. So remove it. Here's a more interesting one, the minification. So this can be done with JavaScript, HTML, and CSS. This is reducing the size of the files, but keeping the function the same. So here we have two JavaScript examples. The top one, they do exactly the same thing, but the top one is taking 200 bytes, and the bottom is taking 28. So this is a big saving in size, and therefore will be quicker to download and to parse. This is an interesting one which not many people know about, it seems. So we can have web pages with a lot of images. For example, a Yahoo web page has 40 separate images. Now, every image is going to be a new HTTP request. So for a page with 40 images, it could take a minimum of 41 HTTP requests. And browsers only have a limited amount of connections that they can use. So if it's 5, then you're going to have to wait 8 times the amount of time for the amount of time for an HTTP request. So a solution here is to combine the images into one file. And what you can do in CSS is then specify the X and Y offsets for these, and the height and width, and then therefore show basically a portion of that main image file. So I have an example of this. So here we have a bit of code I've been working on. One of the pages will load separate image files, and one will load them all sprited. So if we have a look at these two, this is the one which is separate, and then we have one which is sprited. So we look at the performance here. So the separate images, I think that might be cached. Hang on. Let's try that again. Oh, maybe not. So the separate images took 287 milliseconds, while altogether only 246. So last time I did this, it was much, much bigger change than this. It was more about 800 milliseconds. So there might be some caching going on. Yeah. No, found the reason. I'm loading it locally. Okay. So if I was to load this on a local server or a remote server, then generally the figures that I've been getting is that without spriting the images, it was getting about 2,000 milliseconds, while when the images were sprited, it was taking 600 milliseconds, which is an incredible gain. This is the sprite image. This consists of, what was it, 12 or 10? About that, of the images, which I sprited together using an internet tool. And that's what a sprite file looks like. This is a quite useful tool called Sprite Cow. This will, for those that spriting is new to, for those that spriting is new to, this shows how the CSS is formed, and you can basically put your own image in there, and it can output the CSS for you. So here we have an image here, and so if we wanted this Chrome icon, we can just click on it, and the CSS is output at the bottom, and here we have the width and height and X and Y offsets. Nope. Okay. And then, again, this is a fairly common sense one. If you merge your styles and merge your scripts together, there's going to be less HTTP requests. Okay, so this one it's not going to affect the page load time, but it's going to affect the perception of how fast the page loads. This is the best practices for where to put your CSS files and your JavaScript files, or your CSS imports and your JavaScript imports. So put CSS in the head, This allows the progressive page loads, because if the browser knows that there's a CSS file coming up down below, it won't display the HTML that it already has. This is because it will know that it will need to redo the DOM with the new styles. So if you put the CSS files in the head, it can load the CSS files and then progressively load the HTML. So it looks like the page is loading faster. And in a similar way, if you put the JavaScript at the bottom of the page, this means that the HTML file can load before the JavaScript needs to. So when the JavaScript is being loaded, all of the other loading will stop. And so, as I was saying, you may have many different threads loading your page. You may have many different requests going on at once. But if it encounters some JavaScript, it will stop that until all the JavaScript's been read and the JavaScript part is statement in your JavaScript, then put it at the bottom. Because if you do have a document.write, then it will have to rebuild the DOM again, which is a bad thing. An alternate way of doing this is you can leave your JavaScript files in the head, but add the defer HTML5 attribute. This will do a similar thing. It does exactly the same, and it will defer the loading until the HTML has been loaded. And then finally, if you define the image sizes, then you won't have to have as many reflows when the HTML is being loaded. As you might remember seeing back in the old days of 56K modems and earlier, when a page is loading, it can shift all the text because it hasn't got the image sizes on. If you specify the image sizes in HTML, or more preferably CSS, then this won't happen. It will leave the correct space for that image. So caching is a way of producing HTTP requests. There are two main ways of doing caching. Browser cache, which has been around since early HTML and HTTP, and a new HTML5 variation of caching called offline applications. So they are both very useful, and they can both be used, in different situations. Browser cache has been around for a long time, and generally has been done badly. It's controlled by the browser or the proxy, and it uses the HTTP headers to define how to cache and how to get new versions if needed. And so there's a couple of ways of using the HTTP headers as well. I've missed one out here, which is e-tags. But basically, if you put an expires header on being returned from the server, and if you say it's going to expire in the year 3000, then as long as the browser has that resource in its cache, it will never ask for it again. It will always load it from the cache. And it's invalidated with a fantastic word, idempotent request, with a non-idempotent request. This is a request which is supposed to change things on the server. This is such things as a push or a delete HTTP request. An idempotent request is things like a get or an options request. So the other way of caching is using the offline applications. This is now controlled by the app, not by the browser or proxy. So you can define an offline application by specifying a cache manifest, which I'll show you on the next slide. The cache manifest basically gives a manifest of files to download and a manifest of files which can only be served online. And then once the web app is cached, then at maximum there's only one HTTP request per page to check to see if the cache manifest is still accurate. So this is what a cache manifest file looks like. it's split up into three main sections: the cache section, the fallback section, and the network section. The cache section, to start off with, is the list of the files to cache on the device. Fallback section is what to do if those files aren't on the device and it's offline. So at the moment on this, if any files are missing, then it will show the offline.html page. And then the network section will define which pages can only be served on the network. Now you see down here there's a version number. This is how to update your app. So to update your app, you need to change the cache manifest. It doesn't work if you've just changed a file which is referenced in the cache manifest, because it will be the cache manifest which will be read from the server. And if the browser sees that it hasn't changed, it won't bother checking any of the other files. This is how to define that a web app wants to be available offline. You add a manifest attribute to the HTML tag, and this will be where to find the cache manifest on the server. For this one, the cache manifest is on the root of the server, and it will download that manifest and read it. So a quirk of HTML5 offline applications is that if the browser loads contacts the server and realizes that the cache manifest file is different, it will have already loaded the previous version in the browser. And so what it will do at that point is then download every single resource in the cache manifest file. This is a feature, not a bug, apparently. But it will download all of these files, and that's it. So even if there's a new version of the app on the server, the user at this point will see the old version. It won't automatically refresh with the new version. There is a way of checking for this in JavaScript. This is using the window.applicationcache.status property. And you can check this to see if it's updating or has updated, and then use it to reload the page. So you could just do a window.refresh or something similar, or prompt the user, would you like to use the new version? So that's offline applications. So the third part is to do with using HTML pages. So this concentrates more on the user responsiveness of pages. So dive straight in. So I've just taken this brand new web app I've been designing on my PC, running in Chrome. I put it onto my MC65, my brand new MC65, and I've taken it to my boss. I'm like, hey boss, look at this. This is fantastic. It looks brilliant. It's got what? Gradients and opacity changes, text shadows, animations, border radiuses, box shadows, transitions, and transforms. It looks fantastic. Have a look at it working. Here we go. Oh. Sorry, boss, it looks rubbish. So what this slide is trying to say is that you have to be very careful with CSS3. CSS3 does provide a lot of features, but most of these put down here use a GPU if they're on a device with a GPU. For devices like mobile devices, Windows devices, for example, they may not have GPUs, and therefore all of the graphics processing will have to be done on the main CPU. This can make a really bad user experience. So therefore, use CSS3 sparingly. Mobile computers are not desktop computers. So the next section is to do with CSS animation and JavaScript animation. Before CSS3 was around, most of the animation on a web page was done using JavaScript. And what JavaScript used to animate was the set timeout function, which will call a function after a set period of time. So this works just like frames in a a movie. The problem with this is this will make the browser show every single frame. So I've got an example of CSS animations versus JavaScript animations. CSS animations generally seen as better because the animations can be done natively, and styles are pre-calculated, and the browser can decide what the best frame rate is and skip out frames. So another very useful page, well, it makes its point anyway, is this one, and this one is linked as well. This shows the difference between animating 500 boxes in CSS and in jQuery. I'm not sure if this is going to come across very well on the webinar, but we'll have a go. So this is CSS3. Notice as soon as I click it, it will start changing. Ready? Click. So that changed the opacity of the boxes, and it was all done at once, and it looked pretty good. If we do the same in jQuery and click it on here, so that was a lot different. It took about half a second to start animating, and then I didn't actually see any animation. It went straight to black. So this shows the difference between CSS and jQuery. And if we bring up the developer tools again, we can see, if we do, now we'll be using the timeline. If I refresh, and we record, oh no, hang on, I was going, let's clear that out first. Okay, hopefully everything's loaded and we'll see a nice empty box while we record. Okay, here we go. Click. Stop. So when we did that, it only had a couple of, that doesn't look right. Let's try again. Ah, there we go. I wasn't expecting that. I was expecting a lot more. Let's just try the JavaScript instead. Oh, darn. Okay, so this is the JavaScript version. It did everything in here, and there are about 9,500 events being fired here. A huge amount, while it was just, I think there was 45 events on the CSS version. So it wasn't showing very well here, but they've got an example at the bottom here. So this is what happened. This is the events being fired in the CSS version. So something like, I think it's 45. While down in the JavaScript, this continues down for 9,500 styles. So there's a huge amount of processing going on to do every set timeout, while the CSS one is done all at once and recalculated all at once and is much, much faster. Okay. So that's an example. At the bottom there is an example of how it's done in JavaScript. It's using the set timeout here, which changes the opacity by 0.05. And in CSS, it's much simpler. We just set a transition, so the opacity will take a change in opacity will take 2 seconds, and for default it will be opacity 0, and we can change it to capacity 1. And then all the JavaScript will be needed is to change the class name to dark. Okay, so the final section now. So this is to do with getting new data, so changing pages to see well, new layouts and new data. Don't do it. It's expensive. We have to go through all of that navigation again. You'll get a white flash, and it just is a bad user experience. Therefore, a better alternative is to use Ajax. A nice buzzword. It's been around for a while now. Ajax stands for Asynchronous JavaScript and XML. It doesn't need to be XML. It can be anything you want. More often than not these days, people are using JSON or HTML. What Ajax does is it fires off an HTML request, but within the same page, while a normal page load will fire in the browser and the page will be destroyed. This reduces the page load time because you can load out the bare bones structure of your page very quickly if you remove all of the possibly needless data. And then should that data be needed, then an Ajax request can go to the server, get the new data, and inject it into the page. And this also increases interactivity. For example, for form submissions. In olden days, you have a submit button at the end of the page, and it would send off a post message to the server. A white screen will come up, and it will start building a new page. And if you've got something wrong in the form, it will only tell you then. But with Ajax, you can, instead of using the normal page load, you can use an Ajax post, and the page will remain on the same. You might see a processing bar, and you'll get the data back. So this increases usability much, much better. So this is an example of a WebKit, well, any browser apart from Internet Explorer Ajax call. It's nice and simple, and it does just rely on normal HTTP requests and responses, so you don't need to have a special server to do it. Unless, of course, you're doing cross-origin resource sharing, which we'll get on to the next page. So this will create a GET request, which will request this file, ajaxinfo.txt. And this is what will happen when we receive it, is that we are replacing the inner HTML with some response text. So Ajax can be dangerous. For example, if you've loaded up a page on a website, you don't want it to be able to call the page to do a request to get files off of your computer. So by default, Ajax calls can only be coming from the same domain or origin. This is a security aspect. The way around this, for things like using Google Maps in your own application, is a term called cross-origin resource sharing. And this is done on the web server. This basically adds some HTTP response headers to allow other pages to access pages from your server. So it works as a whitelist of domains, or if you don't care who gets your pages, you can just put an asterisk and allow everyone to get access to your pages through Ajax. Okay. So when using a page, what's the best way to change things? So first of all, DOM manipulations are expensive. If you change, add, remove any element, any element on an HTML page, everything the DOM tree will have to be rebuilt, and everything will be reflowed. So here, for example, we're filling a section with data, so we're adding divs with numbers in. So for every piece of data in the data set, the DOM will have to be rebuilt, because the loop will go around, and every time we get it, we're setting the inner HTML of an element to add a new div. So it's not good to do this because it can slow down your application quite considerably. A better way of doing this is to just do the HTML, do the DOM manipulation at the end. So this is a very similar code snippet, which basically adds up the HTML text into a variable and then sets the inner HTML at the end. And so the DOM will only have to be reconstructed once. But this isn't the best solution because this means that the browser will have to parse all of this new text, which is expensive and can take a lot of time sometimes. So a better way of doing it would be to create the elements in JavaScript. So this is an example of creating divs in JavaScript. So we're creating the elements in the document and then appending them at the end. But again, it's a little bit contentious because here we're appending it each time in the for loop. So yes, it'll have to be rebuilt again. So an even better way than this would be to add it to a parent element which is not on the page and then add the parent element at the end. Okay, so another tip for DOM manipulation. It's a very useful little function in JavaScript called eval, and this works by you pass in a string and then it will evaluate the string into JavaScript. Using this, you can pass around functions, you can pass around HTML and all that sort. But eval, this is a contentious issue. Some people will argue against this, but it seems like most people consider eval to be evil. This is a very lazy way of doing things. To pass strings around for functions, for example, you should instead just pass it as an object. It's slow to use because, again, the text is going to have to be parsed by the browser. It's dangerous because other people could inject JavaScript code into your page, and it can make things very, very difficult to debug. But in certain cases, it can be useful, but I won't go into them because they're very, very specific. Okay, so we got just about 10 minutes left. That's the end of the presentation. To summarize, use the internet efficiently, reduce your HTTP requests by what we've suggested, using caching, resource size reducing. User interactions are good, making a good user experience, and therefore page loads are ugly, and use Ajax instead. And while CSS3 is really cool and can produce some really good effects, you've got to use it sparingly and use it efficiently as well. So, but most of all, code well. So that's the end of the presentation. That's the performance bookmarklet link. It's a very useful little program, function. Feel free to use it. It's not mine. So now I'll pass you back to Rob Galvin to see if there's any questions.
Yeah, so thanks, Ben. Actually, before we get to the questions, I did promise you, like I will always on every webinar, to give you a really kind of a cool resource of the week, maybe something that you don't know about, and really kind of cover it in a couple of minutes. While I'm doing that, if you can queue up some questions, we will have a couple of minutes left for some questions at the end. So today's resource of the week is actually a developer tool that you may be familiar with. It's actually one that I used a while back and actually almost forgot about it, and recently used it for helping a real deployment of RhoMobile. The customer was having some issues with their application. And the resource is the Firefox 3D Page Inspector. So this is really cool. I don't use Firefox that much, but this is a developer tool that's built into Firefox where you can actually look at any HTML page, any web page, and show it in a 3D view. So why is that important? Not only, it looks really cool, and I'll give you a live demonstration in a minute, but how is this helpful when it comes to development? Well, in this case where I was helping a customer, they actually were having some performance issues, and they had a single-page application that they were showing different elements and hiding and displaying things. So they had a lot of layers of their application, a lot of div tags that were being kind of laid on top of each other. And we use this tool to really identify some issues, and this kind of relates to some of the things that Ben brought up with CSS. And we actually had multiple layers of opacity, box shadows, animations going on that really were not necessary. So this is a really kind of a cool tool to use to help with that. Not only that, but also you can do some, if you have an application where maybe you have a div tag that's off screen, maybe a menu that you like to slide in and out, this is useful because now you can actually see the content outside of the viewable area by looking in this 3D space. So it's really cool. Let me show you how to use it. On my Windows machine, I actually had to make sure that I had WebGL installed and enabled. In Firefox, it wasn't. So if you don't see this 3D view when you inspect the page, this 3D view button, then you need to go in and actually change and force WebGL to be on. There's a link there to make sure that your machine can support WebGL because it does use the WebGL library for rendering. And here's how you do it. So how is this useful for developing RhoMobile applications? Well, here's one of those things that people tend to not stumble upon. And this is when you're using RhoStudio and you're actually running in RhoSimulator or even on a device, you know that it's essentially creating kind of a local web server on RhoSimulator on the device. And by default, it's kind of randomly picking a port to use. Well, if you go into the RhoConfig option, you can actually change that port so you know where that page is going to be served. So in this case, I'm just changing it to be 8080, and now from Firefox, I can browse to my local host with that particular port to my application. And then I can use external developer tools that are outside of RhoStudio to help with troubleshooting. All right, I'll show you how to do this. So let me just really give you a quick demo. As I said, I would do this under 5 minutes. My screen showing? Okay, there we go. All right, so here's Firefox. This is a kind of a CSS3 menu that's pretty useful for tablets, AT1. So you kind of, on the tablet you would touch and this menu would appear on the left-hand side. So if I bring up the inspector here and look at the 3D view, you can actually see that this content is sitting there on the left-hand side. So it's kind of cool. You can do this to any page. So it's kind of eye candy, but it's also useful in developing. Here's the local application using RhoStudio that's running in my RhoSimulator here. And if I jump into Firefox, I can also take a look at this application as well and kind of see what's going on with the application. So very useful, kind of cool looking, and can help with performance-related issues as well. All right, let me jump back to the slides. So, by the way, I will have a webinar on how to use external tools in general with RhoStudio and developing RhoMobile applications. So, stay tuned for that one. All right, so let's get into some questions. Before we get into some questions, we're running down with time, but since you get to ask me questions, what I'd like to do is ask you guys a question as well while we're discussing the question. So I'm just going to launch this poll up here. If you guys could just respond to that while we go through some of the questions, that would be much appreciated. All right, so first question. This comes from Mark Ben. So he's asking about Ajax. So does Ajax behave differently across different browsers? Is it built into, let's say, jQuery mobile? How is it kind of different between browsers, desktop versus mobile, etc.?
So desktop versus mobile generally is the same. jQuery, you've mentioned jQuery. jQuery is a very, very useful thing because it simplifies the Ajax calls. So Internet Explorer does it one way, which is an ActiveX object to create an Ajax request, while all the other browsers, all the other main browsers, especially WebKit, based browsers uses the XML HTTP request. So if you're developing a cross-browser application, you will need to be cautious of this, because an XML HTTP request may not work in Internet Explorer. But yes, use jQuery to make it a lot easier. But for the calls themselves, it is the same, because it is simply an HTTP request. So between desktop and mobile, they will act very, very similar, all the same. Does that answer any other part of the question I missed there?
I think you generally answered it, Ben. Thanks.
Awesome.
So a couple other people are asking about, hey, this is a good, kind of overview on different performance-related topics. Are we going to be covering other things? Are we going to be doing deeper dives? The answer is yes, yes, and yes. Like I mentioned before in the beginning of the call, we really have a strong focus. We wanted to start with kind of a general overview, and kind of cover some of these topics, but we will go deep on, specific performance-related topics. So I mentioned using developer tools and how to analyze performance. We may even have a full session just on, JavaScript items or CSS3 a little bit more in detail, right, in combination of using these tools. So we will be we may not be able to cover them all in the form of a webinar. We may do some in the form of blog posts. So you'll see a variety of different topics. And also, this has really just been kind of covering the HTML5 piece of this. Of course, we want to spend some time talking about the native side, so, roads applications, particularly, data handling between the roads application, road connect even performance areas. So, yeah, absolutely, we'll be covering a variety of topics on performance. Steve asked this question, Ben, that benchmark tool, I think he's talking about the performance tab that you kept clicking on. Maybe we can provide the URL to that, or how you install that.
Definitely, I'm sure.
Okay.
So what a bookmarklet, I'll quickly explain how a bookmarklet works. So it basically sits on your bookmark bar, and it injects a piece of JavaScript into your page, which will then bring up the visual element. So we can definitely add that to the webinar. I can paste it in the message box if that works, Rob. I don't know.
Yeah, that'd be great, and then I'll share it when I post the recording.
Great. Okay.
All right. Steve also asked, hey, how can we improve the application with rendering the Ruby DRB file? So a lot of these concepts still apply on your native applications, your Ruby views, right? That is HTML. Not so much the retrieving, the issues that have to do with going across the internet, those types of things, but definitely things when it comes to rendering, layout, DOM structure, JavaScript, all of that still really applies to Ruby ERBs. And like I said before, we're gonna spend some more time either in blogs or webinars to cover those topics in a deeper dive and actually walk through some code. Okay. All right. So let's see. All right. So see if there's any other questions. Let me show you guys the poll results. Thanks for responding, by the way. I think if I do this, let's see. It doesn't show that. But anyway, I guess you guys can't see the poll results for some reason, but it looks like you have a couple of know-it-alls. 62% of you, for the most part, try some things. So I think, there's definitely, that shows us that we need to continue to do some of these performance-related topics. I know, and somebody posted a comment there about general perception about developing native apps versus, like a roads application using HTML5 and what's better. We will have another series on just that topic, right? There's pros and cons to both. Too much to cover in the time that we have left, but definitely, a topic to explore some more. So, all right. So it looks like, hey, we actually finished on time. We'll be hosting webinars around optimizing hybrid apps with memory-constrained devices. So yeah, so there's definitely some considerations around some, I guess, lower capable devices when it comes to memory utilization. Maybe in particular some of our CE kind of I forget what group we're calling them nowadays, but the kind of the basic types of CE devices. So we'll probably have a blog post on that, since those types of devices may not apply to everybody, but we will be, covering that as well. All right. So any products that we support today, we want to focus on, as well as everything in general, just to improve your application performance. All right. Any last-minute questions? All right. Going once, going twice. Ben, thank you very much for joining, and I appreciate everybody's participation in attending this presentation. I look forward to seeing you next week when we cover data synchronization directly with the database. So thanks again, Ben. Do you have any last words?
No, it's been really good. Thank you, everyone, for listening. And I'll be listening to the next webinar.
All right. Thanks, everybody. Have a great day.